Thank you, Dr. Nitant, for that very gracious introduction and very rightly setting the tone for today's presentation. So, good morning and greetings to you all for this World Environment Day celebration, although a bit late, but spirit remains the same. So first of all, I'm extremely grateful to all of you for sparing your time on a weekend to listen to this talk, and thank you all for that. So इसको full screen कर देंगे जरा मनीष?
मैडम फुल स्क्रीन है, आप अपने वहां से जूम कर लीजिए, प्लस साइन पे थोड़ा सा क्लिक कर लीजिए तो जूम हो जाएगा।
अरे नहीं प्रॉब्लम, ठीक है चलिए,
राइट हैंड साइड में प्लस साइन होगा।
हाँ नहीं वो करती हूँ तो वो आधा ही हो रहा है, नो प्रॉब्लम, चलेगा, ठीक है, आई मैनेज।
हमें फुल स्क्रीन दिखाई दे रहा है।
हाँ वही प्रॉब्लम, वही एक्चुअली मेरा हो नहीं रहा। एनीवे ठीक है, कोई बात नहीं। सो as Dr. Nitant said, today's presentation is on hashtag beat plastic pollution, remote sensing tools and techniques for monitoring marine plastics. So we all know that this marine plastic pollution is a huge problem, not just oceans, but it's actually affecting each one of us. And also this is one of the major bottleneck in achieving the goals set by United Nations for Sustainable Development Goal, which is 14. In fact, this SDG 14 talks about conserving and sustainability of the oceans, seas and marine resources. So actually it was a very big step by United Nations Environment Program to focus on the solutions to the plastic pollution under the campaign hashtag beat plastic pollution for this year's World Environment Day. So the picture that you see on the screen is actually the global inventory of small floating plastic debris. I will talk on this a bit later, but this is how the distribution of the plastic debris looks like if you look at the global cells. Can you go to the next slide, Manish? So with that brief background, now let's have a look at some of the facts. So these facts have been, of course, taken from the internet clippings. So what you see here is that some of the scary things that are that you can read out from these clips. In fact, such is the huge scale of this problem that around 10 million, nearly 10 million tons of plastics are being dumped in our oceans every year. And to understand it in a better way, that's equal to actually a garbage truck of load every minute, which is huge. And only the 50% of all the plastics that we produce is actually is used, is recycled. That means 50% is for the single-use purposes. We just use them and we just throw them. So what it says is, out of that 50% also, very less, that is less than 9 to 10% of the plastics gets recycled. Either it is like goes into the landfill or it goes into the ocean. And the impact of this plastic is so huge that that 100% of mussels that were tested were found to have were contaminated with these microplastics. And one news says that 1 million marine animals are killed by plastic pollution every year. And the biggest threat and the most alarming news is that there will be more plastics in the oceans than fish by 2050. So that is really very, very scary situation in which we are living today. Next slide, Manish. So let's see the scale of the problem from the ocean side. So as we know that this marine plastic pollution is affecting every country. No country is untouched with this pollution. And over 80% of the pollution that the ocean is witnessing is from the runoff from the land. So essentially, it says that it's all about, I mean, we are the ones who are responsible for this pollution, for this marine debris. So, so just to give you a brief introduction about this marine debris, essentially, it basically it consists of this fishing gears and metals, rubbers, papers, plastics, etc. And these are all created by humans, and deliberately or accidentally they are pushed into the sea. So and out of this 80% of the pollution that the ocean is witnessing because of the runoff from the sea, nearly 90% of all the floating materials are the plastics. So it's a very big number. So only 10% pollutions are attributed to other sources, but 90% is from this coming from the plastic. And actually, in India, we use these plastics very indiscriminately. So we have to be a bit, I mean, we have to think before using this kind of a plastics in future. Anyway, so now I mean, this, I had already mentioned that this marine debris impact is that it kills more than 1 million seabirds and 100,000 mammals and sea turtles every year. So, however, this is the immediate impact. However, there is a far-fetched impact that there are dead zones. However, these dead zones traditionally has been defined, using the oxygen deficit regions, which looks like it may not be directly connected to plastic pollutions, but in future, these plastics which we are introducing into the ocean might lead to many more such dead zones. And in fact, one of the studies shows that these dead zones are increasing dramatically in the recent years. And the last one is the one that mentions that plastic pollution has a strong linkage with the climate change. Again, it may look like what plastic pollution has to do with the climate change, but in fact, the whole process of the plastic production during the whole cycle, there's a lot of greenhouse gas which is emitted, and we all know that what impact the greenhouse gas has on the climate change. Next slide, please. So here what you see is again the global statistics. What you see here is that India's plastic consumption is actually 10th of US, but that is in terms of per capita plastic consumption. So while in the US, the per capita plastic consumption is 109, the India stands at 11. But if you multiply it by the population size, the India's contribution is also very big and very huge. So so that is all about the global statistics. Of course, the China, Europe, all are big contributor to this menace. And if you see how this annual world plastics production has increased over the period of time, so you can see that there is a tremendous increase in the plastic production over the period of time. And if you look at 1950 to 2050, which is a projected rise has also been given of the production, is around 400, nearly 400 million tons. So what you see is exactly, I mean, it is so huge. In 1950, we were hardly using much of the plastics, and now you see where we stand in terms of plastic consumption. So that is what it shows the scary trend of the trends in the plastic use. So this slide basically essentially talks about how this plastic consumption is distributed application wise. And it did not come as a surprise to me that in the packaging industries are using the most of these plastics. That's 24% is attributed to the packaging industry. However, the surprising element in this distribution was 23% use in the agriculture, which of course I was not knowing that how in agriculture we are using these plastics, and that too at such a large scale. But when I did some researching, what I found is that there is a lot of this plastic coated seeds which are being used in agricultural practices for increasing the productivity. So maybe it is giving us a good production today, but it will definitely going to have a very harmful effect in future. And also one of the other practice which is prevalent in the agriculture sector is this using this mulch film, which is usually kept, I mean, used to protect the crops actually, and also to preserve the soil moisture in the soils. So, so nearly 50% of the plastic consumption in India is in these two sectors, in the packaging and in the industrial and in the agricultural sector. And of course, rest of the 50% are in building, housewares, use, transportation, furniture, etc. So, although plastics have become a very integral an important part of global economy, we cannot live without it. We cannot make it zero consumption. That is also because of its versatility, durability, strength, low cost, etc. However, we have to we have to minimize its consumption. So that is what it all talks about. So the next two bullets are basically statistics. I'm not going to talk in much of the detail. Essentially, it tells that there is a lot of increase in the plastic processing industries, and that also shows that how these plastic products are increasing many-fold in the recent years. Okay, so now little bit of plastic. So we know that it is made up of petroleum, ethylene, and polyethylene, and essentially any material which degrades is either by the biodegradation or by the photodegradation. But in the case of plastics, it doesn't degrade by the biodegradation process. Essentially, the photodegradation degrades the plastics. However, when we talk about photodegradation also, it breaks the material into the smaller parts, uh, but still the tiny fragments which are known as the microplastics still remains. So it doesn't degrade completely. It is broken down into small fragments and then in the microplastics, nanoplastics form, but it doesn't go away. So it stays there in the system, and that is the big worry point. And we all know that even these small size plastics are extremely harmful to the marine ecosystem as well as to humans also. Manish, next, yeah. So having seen about that, what plastic is made about and what the problems are, now let us see the essential pathways and the accumulation zones for these for these plastics. So as I mentioned, that the origin is over the land. So obviously the pathway has to start from the land side. So what you see here is that what the green bar says the total annual primary production of the plastic production per year, and the yellow ones which says that how much of the global plastic wastes are being created every year. Uh, what you see is the yellow bar is slightly bigger than the green bar. That is also because in the present year, the previous year's plastics are also getting accumulated, and that is how the wastes are. The waste is more than the production. But that was the land side part. But what is important is the coastal region, and how much of the coastal plastic waste is created. That is very important. And if you look at that, it says that 99.5 million tons per year of plastic waste are generated in the coastal area. When I talk about coastal region, it talks about 50 kilometer from the coastline, and we all know that the 2 billion people are living in this coastal line. So that's a huge number, and it's going to have a very bigger, much bigger impact on the coastal population. Now, out of this 99.5 million tons, 31.9 million tons are still, they are the mismanaged coastal plastic waste. And out of this 32, nearly 32 million tons per year, 8 million tons per year is the plastic inputs to the ocean. So this is what I started when I started my presentation, I talked about this 8 million. So now it is clear from where this 8 million tons per year is, that number is coming. And this number has also been talked about by the UDEP forum. So this 8 to 10 million tons per year, which is dumped into the ocean, is the one which is creating all the problems in the ocean. And most of the regions where these plastics accumulate in the oceans are either in the shoreline regions or the coastal region, and a large amount of them are also advected in the open ocean. So offshore region also has a lot of plastics that you will see in the next few slides.
There's a video. Give me a moment. I'll play the video.
So in the last slide, I talked about this pathways, how it enters into the ocean from the land to ocean side. But now we will see what happens in the ocean once these plastics are dumped in the ocean, and where are those accumulation zones in the ocean. Manish, I'm not able to see the screen.
Ma'am, 1 second. I'm just sharing the video. Which
Sure.
Yeah.
Okay, no problem. Otherwise, you can just keep it static. I can talk about that.
No, I'll take a minute. It's already there. I just need to open it.
Okay, so what you see here is essentially the global distribution of the surface currents, and this is a very long time series of ocean currents that has been generated by our colleagues at SAC using a good resolution of the numerical model, using satellite data and also the in situ data. And what you see here is actually a very beautiful pattern of the surface currents. You can see all those coastal currents, the equatorial currents, the eddies, the small eddies that are being shed by the Agulhas currents. So the reason why I'm showing you this is that once these plastics enter into the ocean, it is these currents which are responsible for its distribution to the different places, and the distributions are actually not the same everywhere. So so that is very important to understand, because it will depend upon the structure of the currents, and also it will depend upon the frontal regions, the oceanic eddies, convergence zones. All those regions are responsible. So there are very few pockets in the open ocean where you will see that these plastic garbages are being accumulated. Go to the next slide, Manish. So these currents actually help us in identifying those regions which are the hotspot regions in the open ocean for these plastics to accumulate. Okay, so that was about the global circulations, and and I told that not all regions have accumulate these plastics in an equal amount. So there are certain regions which are actually known as the large scale gyre regions. Actually, what these gyres mean is that they are the very large rotating system of the ocean currents, and in the northern hemisphere, in fact, they are so large that they can cover the entire ocean, actually, between the two land boundaries. So you can see that essentially here the 5 such gyres are shown here, And actually, what happens is in these are the gyre region in which the central regions are at a higher pressure because the waters accumulate there. So, so when once the water is accumulating there, what it does is it brings all those garbages, including the plastics, of course, to these central zones. So, what scientists have found is that these are the zones which are actually accumulating most of the plastics in it. This is, however, at a very, very large scale. But what happens at the meso scale and what happens at the smaller scale, still we don't know actually. So I will show you in next few slides that how these zones have been modeled and how it has been found that most of the plastics are residing there. Next slide, Manish. So yeah, so this is what I was talking about. Just I took one example of North Pacific gyre. You have many such gyres. I told there are 5 to 7 gyres, scale gyres in the ocean. So this is about the North Pacific gyres, and the left side on it is the region which is the adjoining the Japan, and the right side is the California. And and the water here it's flowing in a clockwise direction. So most of the plastics actually are residing within this gyre. You can see such these plastics garbages which are shown here in this slide. Next. Yeah. So now this was more scientific in nature, where scientists, they went in the ocean with this what is known as manta trawl net, and they collected the water samples. And by analyzing these water samples, they found out the plastic concentration. That is, here it is given in terms of number of pieces per kilometer. So the line that you see here, these round patches is showing you the concentrations. The colors are different plastic concentrations it is depicting. So this is how the samplings are done, and this is how the plastic concentrations are found in the ocean. So but this is of course very, very time consuming, but I will talk about how remote sensing is going to help in this. But essentially this is how these researchers are sampling these waters and then doing these analysis of plastic concentration estimation. Next. So a few more examples. This is in the North Atlantic Ocean, and all those red patches that you see are the zones where there is a high accumulation of plastics, and the blue ones are where the concentration of the plastic pollutions are quite low. And what you see here is that contrary to the belief that the coastal regions are the ones which are having a large amount of plastics, but what you see here is the offshore regions are having the more concentration, and that is of course understood from the previous slides that it's the coastal currents and the eddies that are emanating from these currents. They are transporting these plastics to the offshore regions. South Pacific Ocean also, you can see this is a very, very beautiful concentration map that the scientists have come up with. You see the gyre, and within the gyre, the cross section wise, the sampling was taken, and exactly you see at the center there is a large concentration of the plastics, and on the edges there are very less concentration of the plastics. Next. So this is a slide, if you recall, I had started with. So this shows essentially that out of these the accumulations, large scale accumulation areas in the world, the global oceans, and there are 5 such zones, 2 in the northern hemisphere and 3 in the southern hemisphere. And what you see is towards the Arabian Sea side and in the Bay of Bengal side, there are no such gyres. Actually, there are no permanent gyres, so hence you don't get that kind of accumulation zones here. But that doesn't say that there are no plastics in these oceans. So this is one very gap area where we don't know actually what is happening at a smaller scale. Where are those small scale patches which are there in the oceans. So about these large scale accumulation zones, there is a very good understanding, but at a smaller scale, what happens, that is still a gap area for the scientists to investigate. And I'm happy to share that some of our colleagues are looking into this problem to see how these, what are the hotspot zones in the Arabian Sea and in the Bay of Bengal, especially from the coastal sites. Okay, so the impacts on the marine ecosystem is huge, not just about the macroplastics, because the macroplastics are the ones which are larger in size. More than 5 millimeter size is defined as the macroplastics. So they are quite big. So obviously these marine ecosystems, these marine mammals, they get entangled into that and suffocates, and creates a problem for their survival as well as for their reproductive capabilities. But more than that, the problem is with these microplastics, because they are very small in size, and these marine organisms, they actually engulf these microplastics, and it causes the internal injuries and accumulation of the toxic substances inside that. Next. Okay, this is just one example which I thought of sharing you, because it talks about the scale of the problem. Actually, there is a island which is known as the Midway Island, and it is found in the middle of the North Pacific Ocean gyre. If you recall, I said that in the center of the gyre there are a lot of accumulation of these plastics. So this is one such island, and it is a home to one of the seabirds known as albatross, and basically they eat squid, fish, and krill. And these albatross, they come to this Midway Island for for breeding and for raising their eggs. But what was found is that there was a very high concentration of plastics on this beach, and and it came as such a big surprise to many scientists that inside one of the albatross, inside their stomach, they found a huge amount of plastics actually. So what you see on the right side is the black ones are actually the squids, but on the left there are all those plastics which were found in this albatross. So no surprise that these albatrosses are now becoming threatened and to the extinction actually. So that is the scale of the problem, and of course we all know what kind of a dangers it can create to the human health. In fact, today only in the Times of India it has come that these microplastics, these small particles, are creating huge problem for the respiratory issues actually. They're creating that kind of problems. Next. Okay, so having seen that it is a problem, and we have to maintain the health of the oceans for our future generations. So what exactly we need to do? So tackling this kind of a problem is actually, it requires a multifold approach. When I say multifold approach, it should include the cutting edge research and innovations. There should be a very proper waste management system in place. There has to be a government initiatives and also the large scale awareness. So combined together, if we go in this framework, then only we can tackle this kind of a huge problem. So let me talk about research and innovation. So ongoing research, basically how it helps is that it makes us better to understand the pathways, the sinks, the sources, and what kind of an impact it can create on the marine and the human health system. And there are many innovative technologies and materials, basically actually there are smart materials which are being developed, which are biodegradable and compostable, to reduce the, essentially to reduce the environmental footprint. So research and technologies is going to have a huge impact in managing this kind of a large scale problem. And then plastic waste management, we all know that it is very essential, and because it promotes very disciplined use, collection, and recycling of the plastic waste. There is one very important initiative which has come up, which is called as the extended producer responsibility. Basically, it talks about that the manufacturer who is responsible for producing this kind of a plastic is also responsible for collection and proper disposal of these plastic waste. So that is one again a very good initiative. And of course, we all know that this government of India has several such initiatives in place, like Swachh Bharat Abhiyan, Namami Ganga, and many such Clean India campaign. Many such campaigns are there. And globally also, a lot of efforts are on by United Nations, like Clean Seas campaign, Global Partnership on Marine Litter. So many such global efforts are in place to create awareness and encourage sustainable alternatives. But what I'm going to talk now in my next 2 to 3 slides is about the technologies, and essentially from the remote sensing technology, how we can address this problem and what we can achieve in this section. Next slide, Manish. Yeah. So as I mentioned that we need to have an integrated approach to address the problem. And let us start this with the remote sensing. So we all know that this satellite images can be used to track, monitor the waste in the oceans, and also we can identify the accumulation zones actually. Along with that, we can also identify the illegal dumping sites using these kind of high resolution satellite images. So then comes the drones and the unmanned aerial the UAVs vehicles. So how it helps is if you have to get the information on a very site specific at a very high resolutions, the cameras and these monitors, the cameras and the sensors, they can monitor the coastal areas at a very high resolution, especially the inaccessible regions like rivers and any such places. It can help us, and it can also actually help us in collecting the samples in an automatic manner, which can be later on, which can be analyzed for the scientific studies, and also it can help us in the cleanup efforts actually. Now next comes the in situ data collection. We all know how much useful these in situ data collections data are, because the field surveys and the data collection expeditions can help us in providing a very valuable information about plastic sources, their quantities, their impacts, and very importantly, they can help us in validating the algorithms or the methodologies that we arrive at using the remote sensing observations. And from the in situ and the data, these kind of data collections from mobile apps and tools can also assist in gathering the real-time data for enabling a better decision making as well. And now comes the AI/ML. We all know how powerful these tools are, and these AI-powered actually image recognition can identify different types of plastics actually. So that is the power of AI/ML. And even from the satellite data also, many a times there is an issue with whether these litters are plastic litters or they are for biogenic origin. So this kind of machine learning algorithms help us in classifying those kind of features actually. So it's a very powerful tool, and many scientists and researchers are actually using these AI/ML for classification purposes. And then comes public participation through crowdsourcing, because these crowdsourcing data sets and through these citizen science initiatives, we can have a very strong database creation, and that is extremely useful for making the full use of remote sensing observations. Because right now what people are facing is that this kind of in situ data and this kind of a crowdsourcing data are very less. So maybe these NGOs and all, they can be of very great help in addressing this problem actually. So this was all about how in an integrated approach we can address this problem from the technology side. Now I will talk a bit on specific to the remote sensing aspect. Okay, so coming to the remote sensing and GIS, so this is going to be of this is actually helping a lot in identifying such hotspot zones in the oceans, especially in the coastal zones, because it provides a global perspective of the this kind of a problem that otherwise is very challenging to monitor from the conventional means. And what we can get is the total extent and the distribution of the plastics from using the remote sensing techniques. Of course, they are cost effective, as we all know, and we get real time data from this kind of a platform. And when they are integrated with the ground-based observations and the crowdsource data sets, along with the modeling efforts in the GIS framework, they can be of huge help to the policy makers, which can strengthen the regulations and also guide the resource allocation. Now, one example which I thought of showing you here is on the right side, on the top, what you see is that from one of the cameras on the drone, I mean, researchers had identified this marine plastics, and this was so helpful information that when this Sentinel-2, which has a suite of this optical sensors on board it, when it was launched, this helped a lot in validating the Sentinel-2 data sets for identifying this kind of a marine debris. Actually, now the problem is there is one very big problem when using the remote sensing data, and that is that it's a marine debris that it identifies. It at present on a large scale, it is not able to identify whether uh, this debris is the plastic debris or it is from any other because of any other like seaweeds or foams or any other thing. However, this was the limitation till few years back, but now using the AI/ML technique and other advanced technologies, the scientists are even able to map the hotspot zones of plastics from the Sentinel data on a very large scale actually. So this is how the remote sensing has advanced as regards to the plastic pollution. In fact, when it started, it's a very new actually for application of the remote sensing for plastic pollution identification is relatively new as compared to any other applications. And when it had started, actually scientists started correlating these marine plastics with the derived parameters like chlorophyll, TSM and all, but that didn't turn out to be very fruitful. So, but this RGB combinations of the data sets have really helped. And I'm not going into the details of how it is being done, but there are certain wavelengths which are very sensitive to identifying this plastic pollutions. And these wavelengths are in the visible, in the red edge bands, and also in the near infrared bands. Next slide. Yeah, so this is about our work, which we have carried out. Our colleagues have done at SAC, and they have used the Sentinel-2 A/B data sets, and for some of the identified regions which are marked here, those are the pilot sites. Actually, later on we are going to extend it for the whole coastal regions, because our objective is to map the entire coastal region and identify the hotspot plastic pollution zones. But they have started with this modest beginning. So some of the locations they have identified to start with. And what you see on the right side is one such example where you can see how with time these these plastic floating marine debris, basically floating marine debris from in Sentinel-2 have changed during the period October to November. This is near the Bombay coast actually, and this clearly shows how the temporal variations are happening. And this is the temporal variations are largely it is happening because of the wind wave and the current impacts actually. They are so once it is dumped in the coastal regions, it is taken away towards the offshore side from because of the wind and wave conditions, and also because of the currents. So this is the beginning of remote sensing at SAC as far as the plastic pollution identification is concerned, and I'm sure it is going to be it will be a very large scale effort from our side in making use of remote sensing technology for studying and understanding the plastic pollution pathways as well as the identification. Next slide. So I have come to the end of my talk. So that was all about technology. We know that technology can help us in identifying the problems and in understanding the problems. But at the end, what matters is how we can, reduce the problem, how we can minimize the problem. We cannot make it zero, but definitely we can try hard to reduce the scale of the problem. And there are 5 R's which are being, talked about. Refuse. When we say refuse, we are not saying that you refuse to use the plastics, but just don't use the single-use plastic items. And by reducing, if we can reduce also the plastic items actually, which we can use only those things without which we cannot live actually. So that is another point. And reuse, it should not be just one-time use. And recycle, this is very, very important actually if we have to address this scale of a problem. And my last slide is going to be on this recycle thing. So I'll just talk for a few seconds on that. And of course, we have to redesign your lifestyle. This all we know. So these 5 R's are going to minimize this kind of a scale of a problem that we are facing. Next, yeah. So what in the case of plastic pollution, what we should do is, what the globally it is thought of is that we should not work in a linear economy. That means we manufacture, we use it, and we throw it as a waste. So this is what is the linear economy. But what it talks about is bring the plastics into the circular economy so that it doesn't go away from the economic framework. It stays there, but it is just recycled. So what essentially it means is that keep the plastic raw material in the closed loop so that so that resources are maximally used, and reduce the need of new ones so that new plastics are not generated, and we should and the waste is basically avoided, and these plastics are again recycled in the system and it stays there. So in short, what it means is essentially that the waste of today becomes the raw material of tomorrow. So that is what circular economy talks about, minimizing the waste. So that is what it's all about. So by this way, by taking all these collective actions, we can definitely safeguard the health of the oceans, and we can protect the marine life. And let us do our bit to achieve this one of the goals of achieving clean and safe ocean that is currently under the Ocean Decade celebration, which we are living in the Ocean Decade time frame, which has been proclaimed by the United Nations. So what I urge is that let's do our bit to tackle this menace which the mankind is facing today, so that our future generation lives, they live in a comfortable environment. So I conclude my talk with that. But before concluding, I must thank my colleagues at SAC who have really helped me with preparing this talk. And also, I would like to take the opportunity to thank Director Space Application Center and all the senior management and all the 3 chapters, and also the SAC WED team for giving me this opportunity. So thank you, and thank you all.
Thank you, ma'am, for this excellent talk. Would like, if there are any questions, either you can type it in the chat or you can unmute yourself and ask directly.
Yeah, this is Nitinji, this is Dr. Som Sharma from PRL. Am I audible?
Yes, Dr. Som Sharma ji.
Rashmi ji, first, thanks a lot for really a wonderful and very informative talk on really very novel field, because all type of pollutions are known to that, but this microplastic pollution, which is really going to be a problem, you have very lucidly and you can say informative manner you explain. Just I want to ask a small question, that apart from locating the debris from satellite platforms, is there any other scientific you can say parameter or entity like photic zone or concentration of you can say phytoplankton and salinity or some other oceanic parameter is showing some signature from the satellite platform about the increased microplastic pollution in the oceanic regions? Your voice is not coming. Hello.
Madam, not able to listen to you. नहीं आई आवाज।
Rashmi, your voice is not coming.
आप एक बार म्यूट करके अनम्यूट कर लीजिए या
रश्मि दी, आपका माइक म्यूटेड है।
नहीं, म्यूटेड तो नहीं है, अनम्यूटेड ही है माइक तो, लेकिन
अच्छा, यहाँ से हमारे में म्यूटेड दिख रहा है।
अच्छा, म्यूटेड दिख रहा है।
हाँ, हमारे में म्यूटेड दिखा रहा है।
ओके, नहीं आई, आवाज नहीं आई। मनीष, एक बार एज एन एडमिनिस्ट्रेटर
not
म्यूट करके अनम्यूट कर।
I tried, but it's not working. I'm not able to unmute. Ma'am, can you please log off and join again?
ना एक बार, कोई प्रॉब्लम नहीं। आप हम आपको फोन पे ले लेते हैं मैडम।
नहीं, is it okay?
Yeah, it is.
अभी हुआ, अभी।
Yeah, now it is coming.
Okay.
Now it is coming.
Yeah, fine. Thank you so much. Actually, Dr. Som Sharma ji, that was a very nice question. In fact, when scientists started to think about how this remote sensing data can be used for identifying these plastic pollution zones, they thought of this only, that whatever the data geophysical parameters that are coming from satellites, like in terms of chlorophyll or suspended sediment or salinity, let us try to correlate that with the microplastics. But there was not much success. In fact, there was no success at all in that, because these are all conservative properties actually. So then they thought that, okay, let us move to the frontal regions, whether there are some regions which have a strong gradient, and whether those gradients are the zones where these microplastics can be found. But that was also with a very limited success they could do. So it was found that there is a need to have a direct parameter from the satellite. The basic parameter, in fact, like these spectral content which is available in the optical region, like near infrared or red edge band or visible. And with that, they derived this index, actually floating debris index, and they found that this is working fine. And one more thing, one more aspect was, in fact, in the SAR, this backscatter, they found that there are the traces of these microplastic effect actually, because it affects the roughness of the sea. So there are some papers which talks about the usage of SAR for getting some information about these microplastics also from the backscatter.
Okay, thank you, Rashmi.
Yeah. Thank you, sir.
I have just one small query.
Yes, sir, please.
Yeah, you have given a wonderful lecture, and really a person like me, who is a layman in this subject, really very useful and very informative. So congratulations. And also you have started
for your kind words.
Yeah. And you have started the work on monitoring of microplastics in coastal area. That also is a very good initiative. So compliments to you for that also. Now the question which I wanted to ask is slightly different from the remote sensing applications. It is related to management of the microplastic, because it has become really not only big issue, but it has become a nuisance. See, most of the actions which are suggested are protective in nature. For example, how to protect the inflow of microplastic through the management. Now the microplastic which has already gone inside the open ocean, and you are able to identify, maybe you have given a good correlation with the gyre. Around the gyre they get accumulated. So what kind of remedial measure could be thought of about the plastic which is already in the open ocean?
Okay, sir. It's a very interesting question actually. So the plastics which has already gone into the ocean. Okay. So I think, and they are not even degradable. So I mean, they can become a microplastics, but it stays in the water. So once we,
as you said,
yeah,
that they are not biodegradable, they are photodegradable, but that also doesn't work in the when it is inside the water.
Correct. So if, I mean, I don't know, the only option could be that with time, they aggregate, and surface thing we can minimize, because that can go down in the ocean, but it still stays in the ocean actually. And once we identify these hotspot zones, maybe I don't know, some cleanup operations similar to what we do over the land. So large scale global effort can go in the cleanup operations, even in the oceans also. But that is a huge burden on the economy, I would feel.
Okay,
so there is an interesting point from Sambit that there are some bacteria which are found to be plastic eating bacteria, and it can be grown in the oceans or lakes. So that could help.
But these are all large scale, I mean, long term solutions, but yeah, one of the solutions.
But those bacteria needs to be, so their habitat should be a saline water. Only those bacteria will work there.
Correct. So you rightly said, if such zones are identified very properly, maybe some cleanup operations can be taken up by the government globally. I mean, it has to be a global effort.
Professor Anupam Kumar Singh.
Sir, very good afternoon. You can read, sir, my question actually. That will be better, sir. Thank you.
Whether remote sensing can be employed to measure microplastics in urban water bodies, which algorithm to be applied for feature extraction? Anupam Kumar Singh.
Actually, these remote sensings, in fact, they are good for identifying the macroplastics, actually, the aggregate plastics, not exactly for the microplastics. However, there are some signatures of these microplastics in the backscatter signal, as I mentioned. But for the urban bodies, the issue is that, these bodies are smaller in dimension, extent. So, I mean, unless there is a very, very high resolution data set of backscatter, it's difficult to identify such microplastics in the urban water bodies. However, technology is evolving. Maybe we can come up with high resolution SAR kind of a system, very, very high resolution, and we can get, but the sensitivity still is very, very low. SAR can give you some signature actually. Still today also it may give at 5 meters, 10 meters, but I don't know, the signatures in this kind of a small footprint will be very, very small, and it is indirect effect. It is not that microplastics can be derived from the SAR, but it can just be, some effect on the backscatter can be seen.
Okay,
thank you so much.
But using some water samples and doing very, very detailed spectral analysis of these water bodies may help in designing some future sensors. So it's a good problem, and I think scientists should take it up.
We'll discuss you, ma'am. Thank you so much.
Sure.
Thanks so much.
Yeah, sure. Thank you.
Question from Dr. Ram Rajak is, do you really think enforcement from different bodies can help in spreading this uncontrolled plastic pollution? Although he is in a position of doing the management.
In fact, enforcement, I mean, it's my personal view, enforcement doesn't help much. It's, the social media campaigns, which can raise the awareness, can educate the public, encourage the responsible use of plastic. So that those are the things which can use. In fact, right now there is a Times of India initiative which is going on, Unplastic India. So this kind of campaigns can help in addressing this problem.
Dubey sir, would you like to put your words or the questions?
Yeah, maybe I can try. See, the point is, Dr. Rashmi, first of all, congratulations. I said it's a difficult topic to speak on because it is not something which is spoken of very often. So a difficult one. So congratulations. My point is, let's say I'll take an analogy with the cleaning of River Ganga. The cleaning of a river depends on how clean is its catchment areas, in the sense that how clean are its wetlands, how clean are its rivulets, how clean are the streams. Likewise, if I take the analogy, a clean ocean means that the rivers are clean, because after all, much of this plastic flows through the rivers of world. So there may be certain rivers which bring more plastic than the others. And I feel that one way is to look at the plastic load on the rivers also, and then suggest the measures for the amelioration of this problem. Thank you.
Yes, sir. Very, very, very good point, sir. And this is what our team is looking at. That let us see the complete pathways, how it is coming into the ocean, and which is the root, and where is actually the root problem of it actually. So that identifying that root problem is very, very important. Very good point, sir. Thank you for that.
Okay. Thank you.
Anup Kumar Mandal. His question is how climate change is linked with the plastic pollution.
Yeah, actually, this is one point which intrigued me also, actually. But when I looked at some of the literature, and I mentioned also in my talk that the entire process of this plastic, life cycle, during the entire life cycle, the entire life cycle of the production, the greenhouse gas is emitted. So that is a very, very important thing to look into. And this is one way which it is directly related to the climate change. In fact, one of the articles that I read says that plastic pollution, because of this plastic pollution that we are facing, this IPCC says that that we have to keep 1.5 degree, we have to maintain 1.5 degree rise in the temperature. So this is a very, very big bottleneck. So plastic pollution is not letting it, keeping that kind of a target for us. I mean, to meeting that target. So it has a very strong linkages with the global warming and the climate change.
Sambit, you would like to ask, because one point is you have given this thing about bacteria. Another question you have asked.
Hello, sir. Am I audible?
Yeah, please go ahead.
Yes, you are audible, Sambit.
Yeah. Thank you, ma'am. Thank you for this wonderful talk. I just have one doubt regarding how these microplastics or the overall plastic dumped into the ocean. Do they have any modification in the currents of the ocean? Like any studies have been carried out so that if there is large quantities of such properties available, then do they affect the overall circulation patterns or the physical properties, so that again it will have a feedback loop again and again if you look at a climate scale?
Yes, that's a very, very good question, Sambit, actually. I too felt some time back that, we are only talking about one-way problem, that what microplastics and macroplastics actually are creating to the oceans. But we are not trying to, we don't have that kind of understanding that how it is going to impact the dynamics of the ocean. So what I feel is one way it can impact is like wherever you have this large aggregation of this plastics in the oceans, definitely it will affect the jar circulation. But the time scale would be very, very long. So maybe this is one of the research problem which modelers can think of and introduce those kind of scenarios in their model and look at it, how it is going to impact the dynamics. So at the moment, Sambit, I can tell you only this much.
Bipasha also has a point to be made. Bipasha, can you just put your point, or shall I read it?
Actually, sir, there has been some research going on in devising, that was for the remedial purpose only, that devising this microfluidic devices and using the acoustic focusing for dealing with these microplastics. So those are some new research areas, because to collect them using mechanical devices would be difficult. Only if lot of aggregation is there, then only mechanical devices can help. So some research is ongoing, although it is just in the research phase only. So that was one of the points.
Thank you, Bipasha, for that wonderful point. Yeah, thank you.
And our question and answer session cannot end with a question from Sarangi ji. Sarangi. So Dr. Sarangi says FTIR spectroscopy has or is being used to detect microplastics from water sample.
Yeah, correct.
So it's a point which,
yes. Yeah, he has made a very important point. In fact, using this kind of spectroscopy measurements, this is how it is related to the remote sensing data sets also. So this definitely is helping in developing the algorithms for remote sensing perspective.
Rajesh from NRSC. Can you elaborate, please, on the hotspot regions in the Indian Ocean and which time of the year they are dominant?
Yeah, thank you, Rajesh. This is what we are working on. So we'll let you know in due course of time.
Thank you, ma'am. Thank you for the excellent presentation. Am I audible, ma'am?
Yeah, it's feeble but audible.
Yeah. First of all, thank you very much for a nice presentation, ma'am. Actually, I wanted to put one more point that recently I have come across a paper from CYGNSS team from US. Professor Chris Ruff, they have published a paper on how the scatterometer backscatter is able to pick up these macroplastic hotspot zones in the global oceans. Because the CYGNSS provides a high resolution backscatter, unlike conventional scatterometers which we are launching. So because of the smaller footprint and high resolution, they could study at a broad scale, at a global scale, whatever you have shown the gyral circulation and global hotspot regions, whether they are they could show a map wherein they could match similar kind of accumulation zones using the CYGNSS data. Maybe ISRO also we can think of having a CYGNSS kind of high resolution backscatter platform to give some more information regarding this. It's just a compliment.
Correct. Yeah, that's a very good point actually. I talked about SAR backscatter, but scatterometer backscatter in synergy with this GNSS SAR backscatter will definitely be a good activity to look into.
Yeah, resolution is the key here. So the best resolution, the highest resolution can give some.
No, that's a good science topic to investigate. Yes.
Thank you, ma'am. Thank you very much.
Thank you.
And I was just thinking, like the way in which we are tracking the oil spill, is on similar line, is it possible to track plastics or microplastics or macroplastics?
Actually, microplastics, no. But wherever these macroplastics are there, and that too they are aggregated, so in a large quantity, then definitely it is going to help.
Imran
has made a very good point actually. He has supplemented to what I said, how plastics are impacting the climate change. So very nice point he has made, that the plastics in the ocean affect absorbing capacity of CO2. Yeah.
Yeah, it's just a comment to complement. Thank you.
Yeah. Yeah. Thank you.
Okay. So if there are any more questions or any comments, Rajkumar sir?
No comment. Actually, I came very late. I was on. Sorry.
No problems.
In fact, Rajkumar sir had only shared this scatterometer paper with us, in which there was this signature of microplastics on due to the roughness on the backscatter. So thank you, Rajkumar ji, for that.
So if there are no questions, probably I'll request Rajak ji and Manish to come online.
Yes, sir.
And once again, thank you all. Yeah.
Yes. Yes, ma'am. Thank you for such a wonderful talk. It was indeed a very informative and thoughtful talk given by you on the plastic pollution, which is a topic of great worry as we see it, how it is disturbing and affecting the lives in ocean as well as on the land, and the way it threatens the nature in disastrous way. It was a very informative presentation given by you, where you talked about this facts and figures of plastic pollution and how it threatens the coming future times. You talked about dead zones, how it is affecting the climate, the global plastic consumption, its production, and how it is getting distributed application-wise. The statistics, how it various domains are contributing to the pollution, origin and pathway, and criticality of coastal plastic generation, and statistics at country as well as global level. So it was a very informative talk. Learning how things are linked and how it is disturbing the climate and nature in a longer way. Yes, of course, the tools and technologies available, which are very useful in understanding the situation and handling the situation. You also spoke about those and touched the various points where using GIS, AI, ML, cloud sources can help, and also public participation in way, and the hotspots along the region where the SAC has begun to do the studies. So once again, thank you very much for this wonderful talk. And as a token of appreciation, we would like to do a virtual felicitation of Madam. Uh, and after this So, ma'am, we would like to once again thank you on the behalf of ISG Ahmedabad chapter, ISRS Ahmedabad chapter, SAC, and IMSA for giving such a wonderful talk. And this, as a small token of appreciation, we present you a shawl and a memento. Thank you, ma'am, once again.
Thank you.
Rajak ji, आप अपना कैमरा ऑन कर लीजिए. Yeah. So on behalf of SAC, I request Dr. Rajak to speak 2 words in terms of thanks to the speaker. और रजक, आपकी आवाज नहीं आ रही, आप म्यूटेड हो.
Am I audible now?
Yeah.
Audible? Okay. Thank you, everyone. First of all, let me thank Dr. Rashmi Sharma, who really agreed for this, important lecture on World Environment Day. We know that obviously we wanted to celebrate it on 5th of June, but obviously today she has delivered an excellent lecture, and it is full of suspense. So thank you very much, Dr. Rashmi. And Manish, shall we go ahead with our this next program?
Yes, sir. Indeed, we have to move on to the next item of this today's talk. So we had ISRS Ahmedabad chapter had organized a map making competition on the occasion of World Environment Day, and it was the entries from various participations were received and were evaluated by a committee, and the results announcement is scheduled for today along with this talk. So I'll share the presentation and the result announcement, and I request Rajak sir to kindly take over.
Yes, before we announce the results, Manish, you can display the slide. Before we go ahead with announcement of the results, I would like to thank all the participants who participated in this map making competition. And at the same time, I also would like to thank all the committee members, the SEPT team led by Dr. Shaili Gandhi, and the judges team. Basically they evaluated all the maps, and based on that they have we are giving these gifts. Manish, can you display the slide please? Yeah, so now we will start with the third position. Manish, I am not able to see the slide. Is it visible to other people?
No, not visible. Now it is visible.
Okay.
Yeah.
I think in full mode
Yeah,
it is
Manish,
not
go ahead,
visible.
please.
Is it? I mean, I think there is some problem with the full screen mode.
मनीष या तो वो फुल मोड में नहीं है, आप इसी में you can show the next slide, थोड़ा zoom कर लो उसको.
हाँ जी.
Okay, so let us continue in this mode only, no problem.
Yes, sir.
Yeah. So now we can go ahead with the third prize, please. Manish, you can read it because I am on mobile. I am not able to read, please.
Understood, sir. So the third result goes to the to the poster title Green Cover Change in Chennai for 2016 to 22, and the entry was made by Prajwal Kirti Kumar Parmar from Faculty of Technology, SEPT University. So congratulations to Prajwal. I hope he is available.
Yes, congratulations. Yes, please go ahead.
The second prize goes to the poster title Mapping the Changing Rainfall Pattern over India, and the entry was submitted by Tanvi Birla from ISRS-AC University, Jaipur, Rajasthan. He is also doing a research at ISRO under Dr. Bipasha. And the congratulations to Tanvi. And the first goes to poster title Multi-Criteria Analysis for the Transition of Conventional Energy Generation, PV, and analysis of reduction in CO2 emission by solar energy. This poster was submitted by a team of three students. The team name is Team 5Geo from Symbiosis Institute of Geoinformatics, Pune. So congratulations to Vinit, Suraj, and Aniket for winning the first prize. Congratulations to all the winners again, and parallelly we also congratulate to all the students who submitted their entries and took participation in this event. Thank you.
So congratulations all the winners. Thank you everyone. Thank you.
So Manish, can you give a vote of thanks?
Yes, sir. I am on to this. So once
and उससे पहले एक बार सबके कैमरे खुलवा के can we take a snapshot?
Yes, sir. पहले ले ले उसको. Okay. So
पहले ले लेते हैं.
I request everyone to please switch on their camera so that we'll capture a moment of participation from everybody. Please switch on your cameras. Yeah, on the count of 3, I'll take the screenshot. 1, 2, 3. Thank you. So we once again thank Rashmi ma'am for agreeing to deliver this lecture. It was a very informative and thoughtful details shared by her in her presentation. We also thank Director SAG for all their support and guidance in organizing this event. I thank the chairman, secretaries, and executive members of ISRS Ahmedabad chapter, ISG Ahmedabad chapter, ISRS Ahmedabad chapter, and IMS Ahmedabad chapter, and the committee of WED-SAT. I thank is indeed you for all the audience and participate for their participation in today's talk, and to everybody for coming out with variety of questions, which was again added more information and details to the talk. So once again, thanks to each and everyone who is present here. Thank you.
Thank you all.
Thank you all. Bye.
Bye.
Thank you. Thank you.